Well, good afternoon, everybody. I'd like to welcome you to the latest edition of the WIRE's Technology Webinar Series. And today, I'm pleased to have with us some folks from WIRE's member Great River Energy who are going to talk to us about mobile substations and how they can be used to provide a temporary resource to avoid outages and help with maintenance issues. So to get us started today, I want to introduce Mike Saer, who's the Manager of Transmission Policy at GRE, and with him is Marty Koepke. He's the Supervising Manager of Substation Apparatus at GRE. And before I turn it over to them, I just want to mention to folks who are watching that when we get through with the end of the presentation, we'll have an opportunity for questions if anybody has any while we go through the presentation. Give some thought to anything you'd like to ask either Marty or Mike, and we'll be happy to add those questions at the end. So with that introduction, Mike, let me go ahead and turn it over to you, and we're looking forward to the presentation.
Great. Well, thank you, Larry. And before I begin, I just want to thank you and WIRES for inviting Great River Energy into the Tech Talk to talk about our use of mobile substations. We're excited to provide some information about a technology we've been using for many years. So my name is Mike Saer. I am the Manager of Transmission Policy at Great River Energy, and I'll be teaming up with Marty Koepke to talk about our use of mobile substations and how they compare to other options to maintain grid resiliency. Next slide, please. So before we get into Great River Energy's use of mobile substations, I wanted to provide a quick overview of the company. So we are a wholesale generation and transmission electric power cooperative that provides electricity to roughly 1.7 million people through our 27 member cooperatives. Through these member cooperatives, we serve roughly 2/3 of Minnesota geographically and parts of Wisconsin. Because we are a cooperative serving primarily rural areas, we have a low customer density of about 7 customers per mile, and our member cooperative sales mix is roughly 57% residential, with the remainder primarily being commercial and industrial. And lastly, Great River Energy's membership in WIRES is through Grid North Partners, as Larry mentioned, which is a mix of 10 investor-owned and non-for-profit cooperative and municipal utilities that's teamed up to build more than 800 miles of new high-voltage transmission infrastructure in the upper Midwest. We were previously known by the name CapEx 2020 until a few years ago, but it's the same collection of utilities across the two names. Next slide, please, Drew. So Great River Energy's current generation portfolio has 3 main components. We purchased capacity in an energy hedge from the entity that purchased a coal power plant from us back in 2022, and that purchase is going to step down in increments until the contract expires early in the next decade. And so that's the rainbow energy circle you see on the slide in Minnesota. Great River Energy also has about 1,400 megawatts of reliable and flexible natural gas peaking capacity in Minnesota. Much of that generating capability is backed up with on-site fuel oil, which is critically important for winter reliability in a region as cold as the upper Midwest. And lastly, we have more than 1,800 megawatts of competitive wind contracts that provide carbon-free energy and a hedge to the wholesale energy market. We have been planning and executing the transition of our power supply portfolio for more than a decade, and we are undergoing a rapid transition from a coal-dependent utility to one that is primarily renewable and carbon-free, which puts us in a favorable position to comply with the requirements of Minnesota's new 100% carbon-free by 2040 standard. In addition to our owned and contracted power supply resources, we are also a member of the regional grid operator MISO, and that benefits our member cooperatives by providing access to a vast pool of resources that help maintain reliability. Next slide, please. Given that this is a WIRES production, I wanted to spend my last slide talking about transmission. As part of the roughly 4,300 miles of transmission lines that we own and operate, Great River Energy is also an owner of a significant regional transmission project developed through MISO's Long Range Transmission Planning, or better known as LRTP initiative. The Northern Reliability Project that you see on the slide here is jointly owned with Minnesota Power at about a 50-50 split. And we are currently proceeding through state certificate of need and permitting procedures with the project currently in the scoping phase of development. And we anticipate this project being in service in 2030. So this project is one of 18 that were approved by the MISO Board of Directors back in July of 2022 at a projected cost for the entire portfolio of about $10.3 billion. And we're currently involved with MISO and other stakeholders in the planning of LRTP Tranche 2.1, which is expected to be approved later this year at a projected cost between $23 and $27 billion. So that concludes my remarks introducing Great River Energy, and I'll now turn the presentation over to Marty.
Thanks, Mike, for giving that introduction. And I too want to say thank you for the opportunity to Wires and being able to give a presentation about Great River Energy and our distribution member owners that own Great River Energy and how we use mobile substations to support the member cooperatives. So what I'm showing here is Great River Energy's 5 Minnesota service territories. We also have a service territory located in Underwood, North Dakota. And staffed in each one of these service territories, there are linemen, apparatus, relay, communication, and metering technicians. Each group has their own role in a mobile substation installation. And all the groups will work together as needed to install the mobile in a timely manner. Next slide. Here, Great River Energy has 2 locations for our mobile substation. In Grand Rapids, Minnesota, we have a 5 MVA mobile sub, and in Buffalo, Minnesota, we have both a 5 and a 12 MVA mobile substation. And these mobile substations are stored inside buildings to prevent weather-related damages that can occur here in Minnesota. Our mobile substations are designed to model our cooperative members' distribution substations. They have a high side switch, multi-tap transformer, a low side reclosure, protective relaying, metering, and a communication package installed, along with both a low side cable and regulator trailers, and some even have high side switch trailers too. Next slide. Mobile subs are used for various situations. If there's an emergency, like a failed transformer, GRE will dispatch the appropriate technicians to install the mobile sub. And this also requires truck drivers to move the mobile, line technicians for switching and hooking up the mobile sub, apparatus techs to check the mobile sub operation, verifying that all settings are correct for the distribution sub it is installed at. The relay and meter technicians' involvement, they can remotely call in and to verify settings and operations. And we can also set up crews for a 24/7 operation when we need to get the mobile installed in a safe and timely manner to get our customers back online as soon as possible. Another way GRE may use a mobile sub is to keep our co-op customers online during a construction and or maintenance project. GRE will work with our members to schedule the mobile install and the time frame they want to be on the mobile sub. Since 2010, GRE has installed mobile subs at 23 different member substations. Next slide. Shown here is our 5 MVA mobile substation located in our Dickinson's plant or substation that's in Buffalo, Minnesota. As you can see, there's different high side voltages and configurations and also low side voltages. I wanted to kind of go through the picture a little bit here and explain going from the right to the left of the side of the picture that you see is that's where our high side connections and bushings on the transformer. Then it goes through the transformer to the low side or X bushings, down through the reclosure and to the metering CTs and PTs, and then to the cable reel that is on the back of the mobile. And if you're wondering and looking at the low side voltages there, there's a 2.4 kV delta low side configuration, which was designed at the time. Now, this is an older mobile sub that was built in the 1950s, actually late 1959. And it has that 2.4 kV low side voltage to be used for melting ice on the transmissions line. So what we do at that time is we calculate the line impedance and how much that 2.4 kV current could withstand to yet create enough heat and melt them snow and ice off our lines. We haven't used that too much now as technology has changed and there's new tools for getting rid of ice off of our transmission lines. But back when we first purchased that mobile, that was one of the characteristics we wanted to implement to, again, free up the ice and snow from our transmission lines. Next slide. Here is our 12 MVA mobile sub, also located in Buffalo, Minnesota. This one is configured a little different from our 5 MVA mobile sub. And there's a separate high side switch trailer needed because of the 115 kV voltage. It just couldn't be mounted on the existing trailer. So the way this one is, I'm going to go again from the right to the left. You have your high side, bushings, H bushings on the right, and then going toward the left, then you go through and of course you got your low side X bushings, and then we go through the metering instrument transformers, and then to the reclosure, and finally to the cable terminations. Again, this mobile also needs a separate trailer for the cables, which the other mobile that we had, that other 5 MVA, was part of it. This one has a separate cable trailer that needs to be installed. And then from there we can connect to our regulator trailer, and then finally to the distribution substation. One thing I wanted to note here too, these mobiles here are co-ops continue to improve their backfeeding infrastructure. So, the emergency demand has gotten less in recent years, but it's still a critical part of our resiliency and keeping all our members energized and online. The other thing we have used the mobile sub for is also to install it to prevent overloading depending on weather and conditions, and if there's been a certain line outage, that so our members' transformer isn't overloaded, that we will put in a mobile to help with a backfeed situation to prevent overloading of their distribution lines. Next slide. Shown here is what I talked about earlier, is that 115 kV high side switch trailer that's used with the 12 MVA mobile sub. When that mobile sub goes in, that 12 MVA mobile sub goes in, we first connect from the transmission line down to this switch trailer. And then we go from the switch trailer to the high side transformer on the mobile. And what you see here is the mobile is in the transport mode, and those bushings and switches on the top side actually expand to each side to prevent, so you can have proper phase-to-phase clearance. Next slide. Shown here is a trailer mounted 3-phase, it's a 500 kVA regulator and disconnect switch. The cables that come from the low side of the mobile go to this switches here, and then through the regulators, and then back out to the disconnect switch in the substation in the distribution substation. Next slide. What I wanted to show here is this is our Grand Rapids mobile sub, and this is kind of all the components that go into a mobile substation. As you can see, of course, we have, coming from the back side of the picture or more on the left side, you have the high side lines coming down to the mobile sub. And then it goes from there through the mobile sub down to the regulator trailer. And then after you see the switches on the load side of the regulator trailer, then it goes through the cables and then back to switches located in the distribution substation. We also have a security fence that goes around all our mobiles when they are installed. And this is for security purposes. One of the things in talking about security and safety, once the mobile sub is energized, we have previously installed, before actually it's energized, an equipotential mat. This is basically for the operator safety. So when he comes into the mobile sub, he stands on that mat before touching anything on the mobile, because we have our controls cabinet on the mobile, and we want to make sure he becomes at the same potential of the mobile in case there happens to be a fault. Along with that, on each mobile, we do have a communication package, and that communication package goes back to our system operations. And GRE has their own private radio network. It's a 450 megahertz radio network that gives us real-time loading and status updates of the mobile. So if it ever has, the reclosure ever has to open, we'll know right away from our operations center that there was an outage, and we'd have to send individuals out to take care of it and investigate why that opened. But otherwise, we can just continue to look at real-time loading and monitor that mobile substation so there isn't any overloading or other issues with the mobile sub. And again, most of our member distribution subs are located in rural areas, but there are times it can be in a higher density area, in an urban area. But in either situation, we have remote security trailer that we do install at times that monitors and surveils the area for 24/7 operation. And we do have a security operations center that views that. So in case there's anybody trying to break in or get close to the mobile sub, our operations center can notify security for that. So that's really covering our mobile substations. What I'd like to do next is look at our transformer pool. This is a number of transformers owned by our distribution cooperative members, but maintained by GRE. The 3 GRE-owned mobile substations that we do have are used mostly for emergency situations, lasting less than a month. But if the situation arises where the mobile sub is needed for a longer duration, say like up to a year, well, GRE will then look at installing what we call a pool transformer, which is just a network of transformers that is owned by the members. That way, when we install a pool transformer, the mobile can be available for other emergency needs. Our member-owned pool transformers are used on an average for about 12 to 15 months. And this time frame is usually for, so the removed transformer can be repaired and returned, or if there's a replacement transformer on order and it is to be delivered. The mobile installation for a mobile sub, on average, both installation and removal, on average, is about 3 or 4 times more expensive due to the additional kind of labor and trucking costs. But a mobile sub may be a little bit more expensive, but in an emergency situation, we can install the mobile sub with 100% of GRE resources and not have to depend on an external crane company to move the transformer. So this saves us valuable time in an emergency outage. Next slide. Here in this photo, we've shown a couple of the transformers in our Elk River storage yard. We also have pool transformers located in our Grand Rapids Service Center too. Back in 2005, a group of individuals from the co-ops and Great River Energy got together to establish the transformer pool that would be able to be used by participating members of this pool. The pool committee, which it's called, consists of 7 cooperative members and 4 GRE members that meet annually to review the usage, maintenance costs, and determine if additional spare transformers should be purchased or even existing transformers retired. The committee has a set of guidelines that are sent out to each one of the participating co-ops after the annual meeting. Each participating member, they have to pay an annual fee per transformer they own to be part of the pool. In total, our cooperative members own the 12 distribution transformers, and the sizes range from 10 MVA down to 1250 kVA. Next slide. So what goes into a transformer installation process? Well, when a member cooperative requests a pool transformer, Great River Energy at that time goes and schedules the crane for loading and unloading the transformer onto GRE's lowboy on their trucking department. We'll deliver the transformer. Once the transformer gets on site, either we'll schedule a crane company to remove the old transformer, or sometimes cooperatives do have that scheduled already too, a crane company to remove the old transformer. But we'll have a new transformer installed in place of the old transformer. GRE will install the bushings and the hardware. Then we'll test the transformer prior to energization, making sure that nothing was damaged, and in the move, everything went through smoothly. We also have a Maximo database that we'll update with the new transformer location. And talking about Maximo, that's an asset-driven software package that we use to track all expensive maintenance and operational history of each one of these assets or transformers. This helps us determine the health of our equipment, including all the pool transformers and the mobile sub. And that way we can also, when we have our pool committee meetings, we can then go over that maintenance history and again make decisions on what next needs to be done to an existing transformer. Should it be replaced? Should it be painted? What other maintenance needs to be done? So all that information goes through during our annual pool committee meeting. Next slide. Now we're talking about the transformer removal process. I mean, when the transformer is not needed anymore, either the replacement transformer is here or the rebuilt one is there, then the same steps occur, only in reverse. But what GRE does is we'll also test that new transformer or repaired transformer as recommended by the manufacturer. Then prior to removing the pool transformer, it is also tested. And the reason we do this is, again, we want to make sure that the health of that transformer during the time it was in service, no damage has occurred. So we'll go through a set of tests and verify that the transformer, once it was in service, nothing was damaged and everything was in good condition. Then the other thing is all the installation and removal costs are paid for by each co-op that requires that transformer. So if you have not needed a transformer, a pool transformer, then there's no additional fees except your annual fee for being part of a pool member. Next slide. So I just want to conclude here just to say that, both the mobile sub and the pool transformers, we feel, are needed to be reliable solutions to kind of enhance our distribution network resiliency. It is something our members appreciate. It gives them additional confidence that being their energy provider, we will also look for their loading and their situation to make sure that their customers are online as much as possible. And that's the end of my presentation. Thank you.
Well, great. Thank you very much, Marty. That was really interesting. I want to just mention to people who are watching, if you have any questions you would like me to run by Marty or Mike, go ahead and put them into the question function on the right on your screen, and I'll be happy to share those with them for their responses. I just had a couple of questions I wanted to run by you based on the presentation. Some of this is probably pretty basic, but I don't know the answers to it, so I thought I'd ask it anyway. I guess I'd start by saying, it sounds like this technology has been around for some time. Are mobile transformers pretty common among various utilities, to your knowledge?
Yes, you know, for the network of utilities that I deal with in the Midwest, and you know, throughout other regions that I happen to be talking to, yes, they do have mobile subs. You know, that is pretty common. And like I said, our first original mobile sub was built in 1959, and the latest one we bought was 1980. So they've been around for quite a few years, and you can buy them in multiple different configurations. Now, our mobile subs are mostly designed for our member cooperatives, but you can have, so we just basically have a 115 kV high side as our distribution network voltage, or 69, and then you've seen the other 41.6 and 34.5 that we do have too. But they do come in a multiple configuration, and you can get them in different sizes. There's, you know, larger 30 MVA mobile subs too out there.
Right. So there's no particular limit in terms of a lower voltage on using these. If you've got a system that requires something that's a higher voltage, you could probably order those, or they would be available, I guess.
Well, yeah, you know, if you start getting into the higher transformer, you know, like it's or voltages, you know, transmission voltages, I should say, and you start getting around, you know, 345 kV, there's no mobile for that. But we do have some spare. That's where we keep our spare fleet of transformers for our transmission, kind of separate from our distribution cooperatives, mobile sub and pull transformers.
And in your presentation, you walked through some of the steps for setting up and then, you know, removing mobile transformers, substations when they're in usage. Can you talk a little bit about how much time it takes in order to do that? And I assume there are probably some differences in the steps if it's an emergency situation versus, you know, a maintenance situation where you may not be as under the gun.
Yes, so we've done both. We've had emergency situations where, you know, storm goes through, whatever it happened to be, but the co-op lost the transformer. It failed. It had a catastrophic internal failure. So at that time, it's everybody, all hands on deck, I guess would be the best way to put it. We have 24/7 crews available that they will come in, and we'll get everybody from trucking to engineering to all the line tech, apparatus techs, relay techs, metering techs, whatever is needed to get that mobile installed, and we'll work in a 24-hour by 7 operation, coming in at different shifts. So that time frame in an emergency situation, we can install the mobile, you know, well under 24 hours. Again, depending on how far we have to truck it from where it's at. But otherwise, in normal situation, it can take, you know, 1 to 2 days to install during a 8-hour day frame. You know, some locations, if the mobile sub needs special matting because of weather, you know, say it's, you know, real wet and, you know, not good soil, and the trailer isn't stable, then we'll put matting down, and that takes a while for that to, get placed, and then to place the mobile in and hook that up. So that can be a 2, maybe even a 3-day process.
What kind of fuel do you use to operate these?
What kind of what?
Fuel. What do they operate with?
The mobile sub is just right on right off the transmission line. So right off the transformer itself,
So
it
you don't
just
need a
has
separate fuel source to operate it then.
no.
And then one other question I had was, you talked a little bit about this in the safety context, what some of the differences might be in terms of how you go about using them or anything operational between using it in a more rural situation versus a more urban environment. Is there any difference there really?
Well, probably the bigger challenge in an urban environment is the footprint available. We may, if you get in tighter urban environment, and you might have to pull down a larger part of the existing substation fence just to put the mobile in a little closer to the distribution equipment, and then use the fence all the way around like what we showed in that one photo. But that, and then for sure, like I talked about there too, is the security trailer. That will be definitely, everybody will be like our operations center. They'll have somebody making sure that they're, paying close attention to that, just because of, for the safety of the public, so nobody's trying to climb over the fence or do something inappropriate. So
yeah.
Then you get into an urban area, you can still have issues with that. So again, we will make a determination if we need, depending on how long time frame. If sometimes we've had that mobile go in and it's just due to one of the distribution lines or something internal in the co-op that they can get a quick fix, but it may be in there for less than a week. So might not even use the security trailer for that kind of situation. But usually we try to install a security trailer just so we can have eyes on it at all times.
And then, just so I understand it, once it's set up, you don't have people manning these things, like 24 hours or anything like that. But what are the manpower? Do people go out and inspect them periodically if they're running for a long period of time? What's the commitment for manpower resources on something like that?
Yeah, so manpower resources for that is, again, depending on the duration. If our operations center gets an indication of a tripping, for an example, for sure would be sending somebody out to look at what the reason is for tripping. But say there's also you start getting overload temperature of the transformer, so that oil temp starts climbing, and we start running in close to the high limit. We'll get an alarm prior to it reaching its highest limit. So meaning that temperature is rising, the transformer looks like it's getting overloaded. They'll be looking at the loading from the metering. They'll look at the total KVA loading on that substation. So if that kind of a situation happens, we'll send somebody out there. But say the thing is running just normal and there's no alarm points, we'll check it at least once a month. Again, mobile sub usually is less than a month. Sometimes we've had it in certain situations up to 2 or 3 months, but that's kind of a unique situation, and all members are okay with it, and they know that mobile won't be available for emergency use.
Okay, great. Well, I think that's all the questions that we had on this one. I just wanted to stop and see if you, Marty, or you, Mike, had any additional comments or thoughts before we go ahead and wrap up this session.
Nothing from me, Larry.
Yeah. No, I mean, it's just from our viewpoint and our members' viewpoint, and that it's one of the necessary tools, the way we feel, that you need to have if you're going to operate a transmission distribution network. And like I said, we're always looking at and upgrading our our pool of transformers too. That pool of transformers, they're used probably more often, I know a lot more often than the mobile sub, just because of if there's planned obsolescence to one of our members' transformers and they want to upgrade in size, you know, they're watching their loading all the time. So they will let us know they're purchasing a new transformer for our location, and they'll tell us about the expected delivery dates, and we'll go in and schedule one of the pool transformers to go in. So all that will get coordinated in time that you know, we can put that pool transformer in, have it installed, running, and then if they need that other transformer that's in that substation, or they you know, there's a overloading situation going on and the new transformer didn't come in time, you know, because a lot of times, like in Minnesota, believe it or not, crop drying season for our members is a heavy loaded time of the year in the fall. And so if they expected a transformer from last year, they're saying, boy, they were running close to peak loading of that transformer. Let's get a new transformer ordered and let's have it here in May, June, July timeframe, so we can have it installed before our peak drying season. And something in the manufacturer happens to be delayed, and it's not going to be delivered until, you know, late September, October timeframe, or even later. That's when we'll schedule in to put in a pool transformer to cover a larger pool transformer to cover the load of that whatever smaller one they were going to replace. So.
Well, great. Thanks, Marty, and thanks, Mike.
Sure.
It was really interesting learning about what seems to be a really flexible and an important tool to help with the reliability and the maintenance of the transmission system. So really appreciate your time to talk to us about it today. And I know I learned a lot about something that I wasn't familiar with before today.
Sure.
So thanks again. So with that, we're going to go ahead and wrap up this session. And I want to just mention for people who are watching that our next one is going to be August 14th at 2 o'clock. So we're going to take a little break over the summer till August, and it's going to be with Grid Assurance, and they're going to talk a little bit about their system for pooling important infrastructure for the transmission system. So with that, we're going to go ahead and call this one a wrap for today. And thank you very much. We look forward to seeing everybody on August 14th.
Thanks, Larry.